Hi everyone. Um, First, sorry about my voice. Um, but I'm also sorry I wasn't able to be there with you guys today. But I'm going to go over this section 4.3. So it's not a very long lesson. And hopefully after this, you'll be able to do some homework and then work a little on the practice quiz as well. All right. So what we're going to do is we're going to talk about trig functions of an angle made by a random point. So suppose you were to choose any random point with coordinates x, y, and if you draw a radius to it, then you've made an angle. What do I mean by that? So suppose here is x and y, your two axes, and now if there was a point right here, I can draw a radius to it, and I can call that r. Now, how do I get to that point? I can go horizontally a little bit, x amount. I can go vertically a little bit, y amount. And you notice this is a right triangle. I can put an angle theta there, and I can find sine, cosine, tangent of theta. Now, the way to find these trig functions actually boils down to a couple of formulas, which we can come up with on our own. So if we have our diagram set up like this, where theta is always that angle between, the x-axis and the radius, then it's, let's see, for sine of theta, remember it was always hypotenuse and opposite, so more specifically it's opposite over hypotenuse. So that's always opposite this y over hypotenuse r, and it always turned out that way. So cosine of theta, that's adjacent over hypotenuse, so it's x over r. Tangent of theta is adjacent and opposite, so it's opposite over adjacent x. And once you have that, the rest, cosecant and so on and so forth, are just the reciprocals. So r over y, secant is r over x, tangent x over y. Okay? Now you can memorize these, or once you take a look, you'll see that it's always going to turn out to be the same. These are the same that is listed here. So why don't we actually jump into a problem and go ahead and solve one. I told you before, I always love my steps, right? So here's another broken down into steps. To find the values of trig functions, first, we're going to use the Pythagorean theorem to find the hypotenuse. And in these cases, the hypotenuse is always going to be called r. And the legs are always going to be x and y. The second step is we're going to plug in the values of x, y, and r into the formulas that we talked about right up here. All right, so let's do one here. It says to find the values of the 6 trig functions of theta, and I'm given a point 4, 3. So first let me plot 4, 3. That's right there. So that's 4, 3. Next, I need to draw a radius to that point. Now, if you notice, I can immediately make a right triangle. And the right triangle looks like this. Here is the x value. Here is the y value. All right, so if you look at that red side, how far is it from the origin to this point? That's 4 units. All right, so our x value is 4. And this vertical line, the blue one, is my y value. How do I go from the x-axis up to this point? That's up 3 points. So my y value is equal to 3. But hey, wait a minute. In the point that I was given, I already have x equals 4 and y equals 3. So now I need to use the Pythagorean theorem to find r. Okay, so that's always going to be x squared plus y squared is equal to r squared. So I can either draw it and look at the diagram, or I could just go to the points that I was given, and it's x comma y, 4 comma 3. So here I have 4 squared plus 3 squared is equal to r squared. Now at this point, some of you might be thinking, hey, wait a minute, isn't that a 3, 4, 5 triangle? It is. If you can figure that out and figure out that r is 5, perfect. If you can't, do the Pythagorean theorem and you'll still come up with the same value. So here I have 16 plus 9 equals r squared. 25 equals r squared. So 5 equals r. So just like we talked about, the hypotenuse is my value of r. Okay, now this is all I need. I've got my r, and I've got my x, and I've got my y, and that's all I need. So now I come over here. Sine of theta is always that vertical one, y over r. So that's 3 over 5. Cosine is always x over r, 4 over 5. So if you notice, you can either just memorize and say y over r, x over r, or you could, look at the diagram, visualize the diagram, notice that the opposite is always going to be y, and so on. So any which way, this is what it boils down to. Tangent is y over x, 3 over 4. Now, cosecant is just the reciprocal, 5 over 3. Secant is 5 over 4. Tangent, 4 over 3. And there you have it. Okay, let's go do one more. Here I have another point. X is negative 2, y is negative 1. So I go to negative 2 and negative 1. My point is right there. Now, this is my y, this is my x. Theta is that little itty bitty angle right there. Okay? You don't have to draw the diagrams for me every single time. In fact, you never have to draw them. All you have to do, if you want, is go with the point that you're given, find the hypotenuse r, and then plug them into the 6 trig functions. So let's find the hypotenuse r. X squared plus y squared equals r squared. Now x is negative 2 squared plus y is negative 1 squared equals r squared. Negative 2 squared is positive 4 plus negative 1 squared is positive 1 equals r squared. 5 equals r squared this time. Now I have to take a square root, so r is root 5. So now, x comma y is negative 2 comma negative 1, and r is root 5. All right, so let's go. Sine is y over r, negative 1 over root 5. And that's good enough for me. Cosine is x over r, negative 2 over root 5. Tangent is y over x, negative 1 over negative 2, which is just 1/2. So cosecant is negative root 5. Secant is negative root 5 over 2. Tangent is cotangent is 2 over 1, which is just 2. Okay, so in both of these cases, I was given a point, and the point landed within one of the quadrants. What if we're not so lucky and the point lands on one of the axes? Actually, that's an even simpler situation. So when the terminal side of an angle falls on either the x-axis or the y-axis, that angle is called a quadrantal angle. So for example, suppose I have a point like 5, 0. That's right there. Okay, that's on the x-axis. What angle does that make? 0 degrees. Now suppose my point was something like 0, 4. Where would that be? 0, 4, right there. How big is that angle? 90 degrees. Notice that too lies on top of an axis. That's the y-axis. Okay, so what if I have negative 2, 0? This time my point is on the x-axis on the left-hand side. That angle makes 180 degrees. And then lastly, what if I had something like 0, negative 3? That angle is there, that point is there, and that angle makes 270 degrees. In each of these, I still have an x and a y. X, y, x, y, x, y. When I was doing these calculations, I needed an x, a y, and an r. And what was the r? That was how far it is from the origin to my point. Okay, so let's take a look at this first point, 5, 0. How far is it from the origin to that point? It's 5 units, because I have to go over to the right 5 units. So my r is 5. Oh, look, that's the same number as that. Well, look at 0, 4. How far is that from the origin? How far up do I need to go to reach that point? 4. So r here is just 4. Oh, look, it's just that point. All right, so I could do this for the other two examples too, but I think you guys get the picture. Basically, when a point lands on one of the axes, we have to determine a coordinate point for it, and then the r value is always whatever these numbers are, okay? All right, I've made things very, very simple for us here. So, to find the trig values of quadrantal angles, this is what we're going to use. We're going to use this setup. The one thing you have to remember is, for all quadrantal angles, you're always going to use r equals 1, okay? Always r equals 1. And our points are always going to have 1 as their coordinate. Now, what if I wanted to plot something at 0 degrees? Where is 0 degrees? That's right here. For that, I choose this point, and I always choose the coordinates 1, 0. Okay? 90 degrees, or pi over 2, is right there. For that, I always choose 0, 1. Because how do I get to that point? 0 on the x-axis, 1 on the y. Okay, 180 degrees is here, same as pi. For that, my coordinate is always going to be negative 1 comma 0. And then 270, or 3 pi over 2 is here. For that, my coordinate is always going to be 0, negative 1. Okay, so let's find the values of the trig functions for these angles. All right, suppose we're at 0 degrees, right here. I'm always going to choose 1 comma 0. So x is 1, y is 0. Okay. Sine for this is y over r. Remember what we said? R is always 1. Okay. So for this angle, 0 degrees, what's y? 0. Over what's r? 1. 0 divided by 1 is 0. Okay, what's cosine at 0? That's x over r. What is x value here? 1. Over r is always 1, so I get 1. Tangent is y over x. Y is 0. X is 1 for that point, so 0. Now, cosecant is the reciprocal of the sine. So that's going to be 1 over 0. Anything divided by 0 is undefined. Secant is 1 over the cosine. 1 over 1, that's 1. Cotangent is 1 over tangent. 1 over 0, undefined. Okay, let's do 90 degrees. I'll choose red this time. My coordinate point is 0, comma 1, so x is 0, y is 1. So here, y over r for sine is 1 over r is always 1, 1. Cosine is x over r, 0 over 1, 0. Tangent is y over x, 1 over 0, undefined. And now for cosecant, secant, cotangent, we're just going to take the reciprocals. So for cosecant, it's 1 over 1, 1. Secant, 1 over 0, undefined. Cotangent, what did I get for tangent? 0 over 1 over 0. So this is going to be 0 over 1, 0. Okay, I think I'll just go through 180 as well, and then I'll give you the answers for 270. So for 180, we're here. My coordinate is negative 1, comma 0. X is minus 1. Y is 0. R is always 1. So sine y over r, 0 over 1, 0. It might not be a bad idea if you pause here, try to fill out the rest of the table yourself, and then play it and see if you get it right. That might be a good exercise to do. I'll continue either way. Cosine is x over r. Now we have negative 1 over 1, negative 1. Tangent is y over x, 0 over minus 1, 0. Cosecant, 1 over 0, undefined. Secant, 1 over negative 1, negative 1. Cotangent, 1 over 0, undefined. All right. And I'll just give you the answers for 270. All right, so those are the values for the 270. Okay, so what do you notice? Look at every single answer in each of the 4 columns. What are all of the possibilities that we got? We got a 1, negative 1, 0, or undefined. So for the trig functions of quadrantal angles, These are the only possibilities. You can't get a 2, you can't get a root 3, you can't get a -4. These are it. Okay, so I'm never going to give you a chart like this to figure out, but it's a good exercise to go through it. The way you're going to get the questions are like these. So let's do 2, and I'll show you exactly how I want you to do them. It has to be as painless as possible. So here I want sine of -180. First, let's figure out where is -180. If I draw -180, if that's my initial side, -180, that's right there. I end right there. That is a quadrantal angle because it falls on one of the axes. At that point, what are my coordinates? X is -1, y is 0. So now, sine is y over r, 0 over r is always 1, so 0. Okay? Sorry. Let's do the next one. Sine of -π/2. Okay, where is that? Here is my initial side. -π/2, I'm right there. There's my point. What's a coordinate for that point? X is 0, y is -1. Okay, sine, again, is y over r. -1 over r is always 1, -1. Okay, so there you have it. That's the lesson. And now, with the remaining time, what I would like you to do is 2 things. First, I want you to pick up a practice quiz. And remember that your quiz is tomorrow on Wednesday on section 4.2. And that's going to be an extended period. So right before the quiz, you'll have a few minutes to ask questions, if there's anything on the practice quiz that you haven't understood, and so on and so forth. And then after that, we will take the quiz. So that's happening tomorrow. Right now, I want you to do the practice quiz. Number two, after you've done with the practice quiz, I want you to start on the homework. This homework is going to be due Thursday. Okay? And Thursday we meet right after bonus, so I have lots and lots of opportunities between now and Thursday to ask questions. Okay? Thanks for being such a wonderful audience, and I will see you guys for the quiz tomorrow. Bye.